Hello guys, my name is Sachin Sharma and I am from NIT Warangal, and today topic is a linked list. Okay, so what we will cover in this session? So we will cover almost everything, all basics to medium things in a linked list. So first we will learn how to create a linked list, insertion in a linked list, deletion in a linked list, etc. Okay, so then we will learn the basics of a double linked list and what are the insertion, deletion, creation of a double linked list. Okay, then we will solve some questions, important questions. Okay, from scratch. Okay, and we will also discuss time complexity and space complexity, etc. So what are the question are so find the length of a linked list, reverse the linked list, cycle detection in a linked list. Okay, how cycle detect in a linked list, deletion, if head is not given, then deletion of a node, then how to reverse the double linked list. Okay, palindrome in a circular linked list means circular means yes, it is not circular, it is a single linked list. Okay, so sort the single linked list, and length of a cycle, if cycle is present, then what is the length of a cycle. Okay, then remove the nth node from the end. How to remove the nth node from the end? And sum of two numbers using the linked list. Okay, find the find the middle of an element. Okay, you here the algorithm is turtle and ray and turtle. Okay, rabbit and turtle approach, and how to segregate odd and even nodes, so and etc. or many problems are there. Okay, so these all things we will cover in a one session. So let's start this session, and remember one thing, we will discuss everything regarding the time complexity, space complexity, what are the best approaches. Okay, what are the best of best approaches in a simple terms, in a simple terms. Okay, so let's understand. So I start. So what is a linked list? Linked list is a dynamic structure, as we all know, and it contains the elements. Elements means node, and node contains the two things: a data and pointer. And this pointer is pointing to the next node. Okay, either a next node or some null value. Okay, I'm talking about the single link list. Okay, so how to create this and how a node is looking like. So node look like this. Okay, so there is a value, some values as called data, and this is a pointer called next pointer, and next is pointing to the some node. Okay, and this is pointing to another node, and maybe this value contain the 9, this node contain the 9, and this maybe contain the null value if it is the last node. So how, in this way these nodes are connected, and this is called the single linked list. Then how to create this particular link, this particular node, then this is the structure. So we will use struct node and integer data type, and next is a pointer which is the data type of which is pointing to the node type data structure. Okay, so if I want to create this node, okay, if I want to create, this is the like a class only, and if I want to create a such node, then what I will do, then this is the function to create the node. Okay, so what is in this function, then if I will pass the value, if I write like this, create create node 5, then what will happen, then inside this function, the new is a keyword which is used to allocating the new memory in the heap size, heap area. Okay, new is a keyword which is provide the memory for a node, and how much space the node, the size of a node space. Okay, whatever this size of a node, then it will provide the size in a heap area. So when we pass the 5, then this create a node in a heap area, then and this new node is pointing to this, whatever the heap area memory is allocated. So new is pointing to this node. Okay, new node is pointing to this, and we will insert the value, whatever the value, like 5 here. And next node means next means the this pointer is pointing to the null. So what it will return, this value return the this node. Okay, the value contain 5 and pointing to the next pointer is pointing to the null value. Okay, in this way we can create the node, and this is returning the name of this new node. Okay, so in this way we can create the node. And if I want to insert the node at the beginning, we will see what are the insertion. So first insertion at the beginning of a linked list, and at the any position, and at the end. Okay, so if this is the linked list, if this is the linked list, okay, this is the linked list, and null pointer. If I want to insert the node at the first position here, then what is the process? If I want to position as 2 and 3 position or particular position, then how to insert, and how to insert at the end. So we will see all three cases. Okay, so let's see the how to insert the node at the beginning. So check this code. So this is the code, insertion at beginning, and it is written type is a node type. Okay, so we have a head of a already given node. So this is the node which is already there. Okay, null pointer, and these are the values. So let's change the pen. Wait, if I want to add this node. Okay, if I want to add this node, and this node is create a value, let's say the 5 is passing, so it contains the null value, null pointer. Okay, so as we already discussed, this is the created node, and I want to create this node to insert at the beginning, and this is the head of a already given node, already given linked list. Then I want to insert this node at the front of this. Okay, or starting of this. So what I will do, I will do next pointer uh, of this new node. This is the new node, name of this is the new node, and this is the head. Then I will pass the net, I will pass the address of a head to this, so it will connect like this. Okay, so the new node, next I will pass the head address. Okay, and then I will make a this new node as a head. Okay, so in this way we can make a head, new node as a head, and return the head. So now head is not this, head is this. Okay, then I will return this. So this will become a insertion at the beginning. Okay, now how to insert the node at the particular position. Okay, see this. So I want to create, this is the linked list, you can see this. So 8 nodes are there, 1 2 3 4 5 6 7 8. Okay, so these are the nodes. Now I want to create, I want to add the node at the given position. If the position is 5, remember this, if the position is 5, then I have to add between the 4 and 5, this node at the 4 and 5. So it will become a 1 2 3 4 5, then this will become a 5, and this will become a 6 7 8 9. Okay, so if I want to add any node at the any position, then I have to add that node before the given position only. Okay, so if I want to some node at the 7, then I have to place between the 6 and 7. Okay, then what I have to do, and these are the simple steps. Okay, check this. So we can see that if this is the this is the linked list. Okay, and this is the position where I have to add. I want to add. This is the first position, this is the second position, this is the third, this is the fourth. Then I want to add this position. Okay, then but I what I have to do, this is the head, we all know. Okay, then I want to add this node, add this position. So what I will do, so first I will this, let's say this is the new node. Okay, then I will make it's next to the pointing to this position. Okay, and then I will make this next to this. So first I will connect this new node to this. Okay, then I will disconnect this and connect to this. So so it will be the first, second, and this will be the third, and this will be the fourth and fifth. In this way we can add at any position. So same way this code is working. We created a node, and add is now temp. So if the I the this is the position where I want to add, so I will run this I. Okay, from 1 to that position, less than that position. Okay, less than that position is 1 and 2. Then after 2 I will add now. So I have to run this uh, a loop before the given position. Okay, and temp is not equals to null, so this is not null, so it means the that position is exist in a linked list. And now I am moving one by one, temp next, then I plus plus, temp next, then I plus plus. So this will reach to, when it will reach to 2, then remember I want to add the node at the position 3. Okay, then I am moving this loop um, till 2. Okay, till 2 position. Okay, then when I reach to the second position, then what I will do, check if temp is equals to null. No, it is not null. Okay, it is 2. Then what I will do, then next node. So next node means this. So this is the new node. Then I want to add in new node next. I want to add the temp next. Temp next. This is the temp. Okay, and its next is this. Its next is this. So I want to add. Okay, one thing. 1 minute. Okay. So what I am talking to you. Then I will add. It's a new node. So if this is the linked list, and I want to add at this position, then I will go to till this position before 2, and if this is my new node, then I will add this to this. So first step is completed. Then temp next, this is the temp. Okay, temp, it's a next. In this temp next I will add the new node address. So I will cut this, and this will address this temp next will add the new node address. Okay, then return the head. So add 3, it will add it. So it is very simple. Okay, now to how to insert the element at at the end. Okay, so this is tricky one. What in this? So let's say uh, if this is the linked list. Okay, and this is the end. Okay, and this contains the null pointer last next. Okay, last node next contain the null pointer. Then if I want to add the new element or new node at the end, new node at the end, then I have to add like this, and its next will be the null pointer. Okay, so now see, so I will go, this is the create a new node, and head is a this is the head and temp also, and I will run this temp till now. I will reach to the last node, and so see this temp next is not null. Okay, then till now I will go one by one, and if uh, temp next is a null, so it is the last node. So what I will do, temp next I will add the new node, it's next I will add the new node and return the head. Okay, so in this way we can add the insert the element at the end. Okay, uh, or we have to check one edge case. What is the edge case? If the head is null, means nothing is there, no element is there, then new node itself last node. Okay, if there is nothing, then I want to add this new node, then it's itself a last node, so I will return the I will make a new node as a head, and so new node become a head and I will return the head. So in this way we can make this. Okay, so now we will see the how to delete the node in the linked list. Okay, how to delete the node in a linked list. So check deletion of a node at the beginning, at any position at the end. Okay, so how to delete the node at the beginning? So let's see the scenario. Okay, let's see the scenario. So this is the this is the linked list, and I want to this is the head, then I want to delete this node. Okay, then what I will do, I will take a one temp, and then I will move this head to next. Okay, this and this I will make first head as a temp, and then I will move head to the next of a temp, means here, and I will delete this. Okay, so make see this, I will make a temp head as a temp, then I will move next temp next head, means the temp next is this, so I will make this head and delete the temp. I will delete this and return the head. So in this way we can delete the first node. Then how to delete the node at the position, at the given position? Let's see, this is the linked list and this is the position, and I want to delete this node. Okay, then simple, what I will do, I will go one by one before this position. Okay, then what I will do, I will put temp next, the position next means this. So position next I will put in the temp next, so it will connect like this, so it automatically deleted. Okay, so what I will do, temp next means this. Okay, uh, wait a minute. Okay, now see this. Okay, so what I will do, when I will reach to the temp this, then I will make a temp next means I will make this is a position. So temp next is a position. I will take a one pointer. This is the position. Okay. Then what I will do? It's a next position next. I will add to the temp next. So temp next is this. Then position next is this. Then I will add this. So it's connection like this and this. Okay, and it automatically eliminated, and I will delete this position. Okay, so in this way I can delete the any node at any position. Okay, delete at the end. Okay, so how I will delete? So let's see. So one tricky thing in this is, if I delete the last node, and last node is always contain the null pointer. Okay, if it is a single linked list. So if I delete this now, then I can delete, but this node is pointing to something. So what I have to make sure that it's a last before first node, means last node means this node. I have to make sure it should point into the null pointer. Okay, then I will delete this. So what I will do, I will take a I will go to the last. Okay, last, and I also maintain the one pointer which is just before this, which is pointing to this. Okay, Then I will delete this and I will add it's a next null. Okay, so how I can do this? Let's see. Check this. I will let's say uh, while temp is not null means I have taken the temp is a head node temp means head. This is the head. It is also a temp. So I am moving one by one to the next till what? Till it's become a null. Okay. So it leads to the last, and I also maintaining the s is the pointer. Okay, s is also pointer, node type pointer, which is just storing the temp just before this. Okay, so if this is the last one, then s will be this. So what I will do, then I delete this. Okay, so what I will do, I will add as next as a null. So its next is a null. Okay, and delete the temp. Delete this. Okay, if you want to see the code, then this is the code. And if head is null means nothing is there, so return 0. If head next is null means what? If head next is null means it is a single node linked list only, so delete this and return the head as a null. So nothing is left now, so return null. So these are the two edge cases, if the 0 node and if the 1 node in a linked list. Okay, otherwise I will take a temp as a I will add a I will take a node type temp. Okay, so temp is a pointer which is pointing to the node type data structure, and I initialize the temp as a head. So then I move temp next means I jump by 2. Okay, so what I will do, if this is the linked list. Okay, this is the linked list and this is the null. So when this temp is reached to this now, when I this node is reached to this, its the next is this, its the next is null. So it say it will stop here only, just before the last node. It will stop here only. Then I will put temp. Uh, I will uh, I will delete temp next means this. Temp next is this, and temp next I will put temp next as a null. Okay. So this is also another way to delete the last node. Okay. So let's see what we have covered till now. So we have covered what is a linked list, how to create this, and how to insert at any position first and any position in last, and how to delete the first, how to delete the node at the first beginning, any position at the end. Okay. So so if you are looking for a time complexity, okay, so let's discuss the time complexity of this. Then let's to create this. Okay, so space complexity is order of one, so whatever the size of the node. So if I want to insert the node at first position, then it will take order of time complexity, because it is just adding at the starting. Okay, if I want to add the node at any position, then I have to move one by one. So it will take order of time at first place. Okay, and the number of nodes in list. And if I insert at the end, it definitely take a order of time. If the size of a linked list is the contain the n nodes. If it is contain the